Hey guys, thanks for tuning in today. And today I'll be going over this legal question to keep myself accountable, but also help you guys improve your lead coding skills for any interviews that may come up. Okay, so today we're going to be solving this question: the latest time to catch a bus. You're given this zero index integer array with this length, where bus is at index I represents the departure time of the ith bus. You're also given a zero index integer array passengers of length m, where passengers j represents the arrival time of the jth passenger. All the bus departure times are unique. All passenger arrival times are unique. Okay, so um, you're given some sort of capacity where each bus can only hold a specific amount of people, and we're trying to see if we can fit we're trying to see what is the latest time that uh, we can arrive at to catch at least one of the buses, right? So if we can catch on the latest bus, that'll be the best. That'll be the best answer, right? We're trying to find the we're trying to return the latest time you may arrive at the bus station to catch a bus. You cannot arrive at the same time as another passenger. Okay, so no bus arrays are not necessarily sorted. Okay, so given that we're dealing with increments in time, we should actually be sorting the array first, because we need to know when the buses depart. So actually, let me just start off by saying that we need to sort both buses and passengers array. This is for sure because of otherwise it'll be hard to keep track of um, what passenger got on which bus. Next step, let's just do like a dry run, right? So let's do the first one. So once both buses and passengers are sorted, let us do a quick calculation here. Why don't we manually figure out how we're getting our answer, right? We see that uh, bus leaves at 10, t equals 10, but this passenger arrives at the bus stop at t equals 2. So that means this person can get on this bus. But the moment we increment some sort of pointer to here, 17 can't get on this bus because this bus leaves at t equals 10, right? And as long as we can get on that bus that departs at x minutes if you arrive at y minutes, where y is less than or equal to x. So if we arrive at 10, we can get on this bus here, right? So 10 is possible. We know 10 is possible for sure. Uh, let's move on. So we got 17 is less than 20. So we see that 17 is greater than 10. So we need to increment this 10 to this index, which is 20. We see that 20 is indeed greater than 17. So this is okay. This person can get on this bus. 18 can also get on this bus, but 19 cannot since we're at capacity. Capacity is specified to be 2 in this question here, which means we must come at 16. So 16 is possible. Remember, we cannot come at 18 because 18 conflicts. We cannot come at 19 because that means we conflict and we're not going to get on this bus since we have a max capacity of 2. Only the first 2 people can get on this bus. All right. So, given that, given what we know, why don't we try to figure out what the best time, what is the best time here? And we see that clearly the best time here is 16 for us, right? And this is the answer. So why don't we run like a for loop? We need to run a for loop here for t in buses, right? We're trying to see how many people can get on each of these individual buses. So we need to keep track of a current capacity. We also need to keep track of mm, I think that's it for now. We just gotta make sure we're not overloading any of the buses with too many people, right? So then we're gonna check, okay, how many of these passengers can we fit on here? And to determine who gets on here, we need to set a passenger pointer. I'm gonna call p pointer equals 0 here. And what we're gonna do next is we're gonna be checking. So if this passenger at this pointer, if this is less than the less than time. Mm. Oh, and also we got to make sure p pointer is less than the length of the passengers array to ensure we don't go out of bounds, right? So this condition must always be true. Um, and we're also checking to see if passengers. We're trying to see if this passenger's arrival time, which is 2, is less than um, t, less than or equal to. If so, we set current capacity. We're going to increment it by 1. And we're also going to increment p pointer by 1. Because we know that this person can get on the bus for sure, right? We also have to make sure that cur capacity is less than the actual capacity. Because we can't let people on the bus, right? If we reach maximum capacity. So for each of these buses, we need to reset the current capacity too here, because every bus will a new bus will be empty, right? So we will have to reset the capacity here. Now the other case is there has to be some sort of way for us to keep on letting people on the bus until this condition can no longer be fulfilled. So we actually need to run a while loop here. Since running it once will not do anything but allow only one person to get on. We gotta see how many people we can let on this one bus. So we need to have a while condition here. So while this condition is true, we can keep letting people onto the bus here. And finally, let's just print out p pointer to see who is the last person to get on this bus. And all we gotta do is show up before this person. Or, yeah, basically show up before this person, or we show up ahead of time before the last bus leaves. Yeah. Okay, so we see that pointer is 3, so 0, 1, 2, 3. So we actually want pointer minus 1, since we still increment p pointer even though we are technically at capacity. So we actually want to be in this position here. Why don't we write this down? Actually, let's just sort it to make things easier for us to visualize. 9, or 13, 19, 21, 25, 26. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Okay, good. And the buses are here. The buses are 10, 20, 30, also in sorted order. So we see 4 gets on this one, 11 cannot get on 10. So 10 is possible. Then we see 11 can get on 20, 13 cannot get on 20. Okay, we see that 12 is possible. And we see 19 can get on 30, 21 can get on 30. So 20 is possible. So we identified that the last person who can get on these buses is the guy at 19. Right. But there are more passengers that don't get on this bus. So we can actually get on. Wait, so 4 goes there, needs to get on there. And 19 can get on the 30, and 21 can get on the 30 as well. So the last person is actually over here. So that is 0, 1, 2, 3, 4. And then the pointer will now be at PTR, will now be at the fifth index, which indicates from here on forward, these passengers do not get on the bus, or cannot get on the bus, right? Print T is this, and let's figure out who gets to be let on. So print PTR, PTR 20. So these people can be let on the bus, right? What about over here? Oh, oh, I forgot to sort them actually. I said I was gonna sort them, but I didn't end up sorting them. So here we are. Buses equals sorted. Buses. And then passengers equals sorted. Passengers. There we go. Now this returns 4. So 0 can get on this bus, and then these two can get on that bus, and then these two get on the 30 bus, right? And let's see. 0, 1, 2, 3, 4. So that's right, 21 can get on this bus. Okay, so now we figured out what time is the last person that can get on this bus. So now let's figure out what is the best time for someone to get on, um, for us to get a seat on one of the buses, right? So if P pointer, if the current capacity is less than capacity, what does this mean? From this statement here, it means that for the last bus, there's actually one more seat we can have. Let's pretend, what I mean by that is, let's pretend these values don't exist. Or we have like 41 here. What I mean by that is, obviously, this person cannot get on the 30 bus, right? But capacity here is at 1. We can fit one more person in. That means I can take all the time in the world and I can get on at time equals 30. If that's the case, then my best time is actually the buses is the last bus, right? Even if this guy is like late, my best time is still 30 because I'll be getting a seat, and this person will not be getting a seat regardless of uh, if I go or not, because this bus will only be at capacity 1. However, let's say the bus is filled up, right? So we got 21, 25, and 26. All right, we need to show up before this guy shows up. So our best time is then passengers at PTR. Okay, now we gotta check something. I said that our best time is now 21, but we clearly cannot arrive at the same time as this person. So we actually need to arrive before this time. So why don't we um, check? Okay, while best time in passengers, we want to do best time. We want to decrement best time by 1 and keep trying until we find the actual best time. Then we return best time. What I mean by this is we see that 21 is in passengers, so we try 20. And we see 20 isn't, so we return 20. And we keep decrementing best time by 1 until we find the best answer, the best time, such that we can arrive the last. Right? So we return best time here. But this over here is not optimized. We're basically checking a list. We're checking 4, then we're check. Okay, does 21 exists in, is this 21? We're basically checking each element one at a time, right? So worst case scenario, this would round to O of n time check. And let's say we have a array of like 1, 2, 3, 4, 5, 6, 7, and we're checking from 7. That means we're checking everything n times. We're checking n times until we figure out that um, the best time to show up is 0. That time is 0. So we need a better way to do this. And the best way to do this is sacrifice O of n time by turning passengers into a set, such that each lookup is now O of 1. So we do we sacrifice O of n time to make this into a set, so that our search can be heavily optimized, right? So why don't we check our answer with this? Oh, output is 24. Oh, pointer -1. Oops, I forgot about that. We want pointer -1. And that should be it. Okay, now let's move on to analyzing the time and space complexity here. So we see that buses over here, we sort them, and we also sort passengers, right? So let's just say um, this is n, and then this is m. That means that what we're doing here is we're doing O of n times log n, and over here we're doing m of log m here. So we're doing this plus that. Over here plus this is n, right? And then we're doing like a kind of like a two-pointer approach here, where we keep on incrementing p pointer as long as this condition is true. We're not going back to the start and going forward again. We're just keeping our position p pointer as we're going along with buses. So this for loop here, or this nested loop, is actually O of n plus m, right? Over here, you're making this into a set, which I've discussed earlier, which is O of n, or rather O of m. And then the lookup is the lookup is um, O of 1 time. But worst case scenario, we check the entire passengers array, which is still O of m. Because let's say we have an array that's like 1, 2, 3, 4, 5, right? And our best time is somehow 5. Then we check, is 5 in there, is 4 in there, is 3 in there, is 2 in there, is 1 in there. So therefore this is O of m time plus O of m plus O of n plus m plus um, O of n log n plus O of m log m. So the time complexity is actually just O of n log n plus O of m log m. As for space complexity, we're not using anything. Um, we're not making like a new array. We're just keeping static variables. So space complexity is just O of 1.